So we have discussed the loss of kinetic energy during impact. Okay, so there are two bodies. One is body A whose mass is m1, initial velocity u1, and after impact its velocity become v1. And similarly for body B whose mass is m2, initial velocity u2, and after impact its velocity become v2. So what is the kinetic energy before impact? So kinetic energy before impact is that half m1 u1 square for body A and half m2 u2 square for body B. So this is for A and this is for B, and this is similarly after impact it's become a half m1 v1 square plus half m2 v2 square. So what is the loss of kinetic energy during impact? So kinetic energy loss is determined easily by subtracting these before impact kinetic energy minus after impact kinetic energy, and half is common in both expression. So we have found that this. So by multiplying this term m1 plus m2 above in numerator as well as denominator, we have final expression become this. Okay, and after solving this equation using some mathematical tool like this, you multiplied this term, means simply you can export the bracket, means half m1 is multiplied by this m1 square u1 square, m1 multiplied by m2 u2 square is become half m1 m2 u2 square, m2 is multiplied by this m2 m1 m2 u1 square, and similarly m2 multiplied by this is m2 u square plus u2 square. Okay, and similarly for this second term. And by solving this equation m1 u1 square plus m2 u2 square plus m1 m2 u1 square plus u2 square, and this expression. So how can we solve this expression? So as we know that this m1 square plus m2 m1 square u1 square plus m2 square u2 square simply written in this way. Similarly m1 m2 u1 square plus u2 square written in this way. So by simply you can add this these two equation to obtain this expression m1 u square plus m2 u2 square plus m1 m2 u1 square plus u2 square. The final expression become m1 u1 square plus m2 u2 square. Okay, and this term will be cancelled out. Okay, and plus m1 m2 u1 minus u2 ka whole square. Okay, so our next part is that this. So finally this expression, after solving this above equation, we have found that m1 u square plus m1 u1 plus m2 u2 ka whole square plus m1 m2 u1 minus u2 ka whole square. And similarly we can solve for this expression, and we have found that m1 v1 plus m2 v2 ka whole square plus m1 m2 v1 minus v2 ka whole square. So simply these larger term, these large terms will be simply simplified in these two terms, that delta is equal to 1 by twice m1 plus m2 m1 u1 square plus m2 u2 square plus m1 m2 u1 minus u2 ka whole square, and similarly this term. Okay, so according to conservation of momentum, this is the linear momentum before impact, and this is linear momentum after impact. Okay, so by squaring on both sides, we have found that m1 u1 plus m2 u2 ka whole square plus m1 u1 plus m2 u2 ka whole square. So it simply shows that these two terms will be cancelled out, and the remaining terms are in such a way that the remaining terms are this. Okay, m1 m2 u1 minus u2 ka whole square minus m1 m2 v1 v2 ka whole square. So we know that the coefficient of restitution E is equal to v2 minus v1 u1 minus u2. So by equating this value v2 minus v1 is as E u1 minus u2, okay, in this equation, so we can easily obtain the final expression in this way: m1 m2 u1 minus u2 whole square minus m1 m2 this, and E square u1 minus u2 ka whole square. And by taking this m1 m2 u1 minus u2 ka whole square as common, and the final expression become this. Okay, the final expression is this: delta E equal to, this is your final expression, delta E is equal to m1 m2 twice m1 plus m2 u1 minus u2 whole square 1 minus E square. So this is your final expression for the loss of kinetic energy. So first case is for the inelastic collision. So as we, for inelastic collision E equal to 0, and as we put E equal to 0 in this here, so this equation is simplified in this way: m1 m2 upon twice m1 plus m2 u1 minus u2 ka whole square. So this term is simply known as the harmonic mean of mass m1 and m2. That is simply HM series. You can already know about the HM series. Okay. And for the second case, for the elastic collision, so as for the elastic collision, this as we put E equal to 1, this term equal to 0, so delta E equal to 0 means the kinetic energy before impact is equivalent to the kinetic energy after impact. So now we come to the simple problem, and that problem is, there are 3 parts. Okay, so one by one. The first question is that during elastic impact of 2 equal masses, there occurs exchange of the velocity. Okay, so how can we solve this equation? Is that, so consider there are 2 bodies. Okay, there are 2 bodies whose mass is m1, initial velocity u1, and after impact velocity become v1, and another mass m2, initial velocity u2, and final velocity become v2. Okay, so according to law of conservation of momentum, this equation, this expression is m1 u1 plus m2 u2 equal to m1 u1 plus m2 v2. So since the both masses are equal, okay, so as the both masses are equal, so this masses will be cancelled out. Okay, and we have found that the u1 plus u2, v1 plus v2. So the coefficient of, according to coefficient of restitution for the elastic collision, E equal to 1, and as we put v2 minus v1 equal to u1 minus u2, as we put E equal to 1 here, and by solving this equation and this equation, we have found that this v1 is cancelled out, and we have found that 2v2 is equal to 2u1. So 2 will cancel out, and we have found v2 is equal to u1. Okay, and the next question is that, in the next question, the collision of, when a body strikes an immobile body. Okay, in the next question, the body strikes with immovable body, means there one body is m1, u1 and v1, and immovable means m2 is equal to infinite. Okay, and m2 is equal to infinite because m2 is larger mass, and its u2 is 0 and v2 is, okay, so according to conservation of linear momentum, this divided by the m2, okay, and m2 is infinite, so these two terms become 0. Here there is a v1 term, so u2 v2 equal to 0, and for perfect elastic, E equal to v2 minus v1, so u1 minus u2 equal to v2 minus v1, so u2 is 0, v2 is 0, so u1 equal to minus v1, means the ball rebounds with the same velocity with which it strikes the floor. Okay, and the next question is that, in the third part, the when a body strikes another body of equal mass at rest, means the u2 is 0, and both have same mass. So according to conservation of linear momentum, this expression becomes v1 plus v2 equal to u1, and for the elastic collision again, v2 minus v1 equal to u1 minus u2. Okay, and by solving this equation, v1 is cancelled out, and 2v2 is equal to u1. Okay, because u2 is already 0, you can put u2 is 0, so 2v2 is equal to u1, so v2 is equal to u1, and v1 is equal to 0, means the entire velocity to the other mass, the entire velocity will be transferred to the another mass, and itself it becomes rest. Okay, so thank you. In the next video I have discussed one more question.